Pre-calculus students, welcome to the rest of your 9.1 notes. Today we're going to focus on parabolas. Now some of you may realize that we've already talked about parabolas in this course. We have. We're going to look at them from a little bit different perspective today. So we're going to focus on the conic form of a parabola instead of the functional form that we looked at earlier this year. So first of all, the standard forms for any parabola with a vertex of h and k looks like the two equations you can see right here. The first is that when you have a vertical axis, and by vertical axis we mean axis of symmetry. So that a vertical axis implies that the parabola is going to open either up or down. And then the second version is for a horizontal axis. You'll notice these are not functions. You could not graph this on your TI-84, at least not in one step, because it's a y squared term instead of an x squared, not a function, but we can still graph them when we think of them in terms of conics. There's some terminology to consider. I've got a lot of it graphed here. We already talked briefly about the axis of symmetry. But also we have the vertex. That's not new. The directrix, we're going to talk about that quite a bit more today, and the focus. Those two have a relationship with the vertex, and we'll mention it now. They're always exactly p units from the vertex. That's for both the focus and the directrix. So if we go p units up, we find the focus, p units down, we find the directrix. That is in the scenario of a vertical opening upward parabola. Okay, there's one more thing I want to actually point out. It's not defined on there, but I'm going to draw it. It's the width of the parabola at the focus point. No idea where that little picture came from. All right, and we have a name for that, and it is called the lattice rectum. Yes, there are giggles on the other side of the screen. I can hear them. I can hear you when you watch these videos. I know. All right, so the lattice rectum is the width of the parabola at the focus point. And the best part about it, the cool thing about the lattice rectum, is it's always equal to 4p. So when you have it in standard form, your lattice rectum is this number right there, the 4p. All right, we're going to continue on. I'm not going to spend much time on the next slide because it's just distinguishing opening up versus down and right versus left. The biggest thing, if you want to be able to know the difference between up and down, it has to do with if the p term is negative. If it opens to the left, it's also p is negative. Okay, so there are sort of four versions, but they're all working the same way. Positive is either up or right, negative is down or left. It's probably somewhat intuitive. All right, up next, what we're going to do is we're going to kind of work our way through the clue problems that we have for this chapter. So we'll start with this one right here. Find the standard form of a parabola that has a vertex at the origin. That's important. I'm going to underline it here. And has a focus at -3, 0. Now I know that nowhere in these instructions does it say that you need to draw the parabola. You don't have to sketch it at all. But I'm going to suggest to you that just doing a quick sketch like I'm about to do can really be helpful as you work on this. So I know again that the vertex is right there at the origin. Focus is -3, 0. Now one thing you'll note is I'm not really trying to sketch this with precision. I'm just simply trying to get an idea. So some of the key things that I know from this is that since I have a drawing, I know that this opens to the left. That's important because it helps narrow down which equation we're going to be using, which form. The p-value is, again, the distance from the vertex to the focus, this distance right here. And we know that it's 3. Now, in this case, because it's left, I'm going to go ahead and call it -3. And we know the vertex is at the origin. Now, if you looked back a couple slides, you see we had actually two different versions of this equation we could use. I'm going to go ahead and just use the broader version. So we know it's going to be y minus k quantity squared is equal to 4p times x minus h. Okay, and again, the way I think about this is I know it's y squared because this is not a function. Not a function, y squared. If it is a function, it's going to be x squared. All right, now the things we know the vertex is at the origin, so I'm just going to have y squared equals, well, 4p would be 4 times negative 3, and then x minus 0 is just simply x. So our form is going to look like this. It's going to be y squared equals negative 12x. And that's where we stop. You don't want to try to change them into some other form. There's not another form. We're going into that conic form only. All right, let's do another one. This time we're going to go ahead and start with a little bit of a sketch. And again, you probably won't find instructions that say, before you do the clue questions, go ahead and draw it. But let's be realistic. If you want to, figure these out, it never hurts to do just a quick sketch. And again, I'm not looking for precision. I'm looking to know things like, I want to know the direction. And by sketching the vertex and the focus, I can quickly see that this parabola is going to open upward. It might visually help me to see the p-value because I know from 4,3 to 4,8, we're talking about this distance right here. We know that distance is going to be 5. And that's really honestly all we need to know. Since this is a parabola that opens upward, it's going to be x minus h squared is equal to 4p times y minus k. And in this particular case, we know the vertex was given to us right up here, 4 and 3. So I'm going to go x minus 4 quantity squared. We found p to be 5, so I'm just going to go ahead and change 4p to 20. And then y minus k would be y minus 3. And we're done. We don't need to do any other work. We don't need to simplify. We don't need to multiply anything, distribute anything, square anything. None of that stuff is needed. That's it. That's your conic form.
Okay, question 3 gets a little bit more involved. So we're going to walk our way through it. So just follow along and pay attention. I think the first thing we'd probably all notice is none of us really want to have to deal with these fractions. So I'm going to go ahead and multiply everything by 8 and rewrite this to be 8x is equal to y squared minus 6y plus 41. Okay, my next job is I'm going to go ahead and bring the 41 over to the other side. Now I know to do this because what I'm trying to do here is I want to complete the square with the y squared minus 6y. All right, so I know half of 6 is 3, so I'm going to go plus 3 squared, and if I go plus 3 squared on one side, I've got to do the same thing to the other, so I'm just going to write it as plus 9. So then I'd have 8x minus 32 is equal to y minus 3 quantity squared. And finally, I'll go ahead and factor out the 8, and I'll have 8 times x minus 4 equals y minus 3 quantity squared. Okay, now that's sort of flipped from the order we're used to seeing it, but that's no problem at all. Let's go ahead and start listing some of the key information, and it asks us for a lot of it. We're not going to do it in the same order, but what I do know is that the vertex is at 4 and 3. That comes from the h and k values that we see here. The 8 out in front tells me that I have a p-value of 2. Now I know it didn't ask us for the p-value directly. By the way, I'm going to explain where that came from just a little clearer. 4p equals 8. So we know p equals 2. There we go. Didn't ask us to state p, but if we're going to do this problem anyway, we really need to keep that in consideration. So I'm going to go ahead and sketch start sketching the graph a little bit. And let's see. So again, we know the vertex is at 4 and 3. I'm just going to approximate where that might be. 4, 3. We'll just say it's there. And here's the thing we know. It's y squared. That tells me that this is not a function, which means it opens either right or left. P-value is positive. That tells me that this graph opens to the right. And the fact that P is 2 means that my focus, there's my focus point right there, is going to be 2 spaces to the right of the vertex. And the graph will open something like this. Also, because of that p-value, we can actually find the axis of symmetry. We know the axis of symmetry is always going to be p units from the vertex, so it's the same distance from the vertex as the focus is, and that will allow us to find the equation of the directrix as well. So let's start going through this. The things we know, we've already got the vertex. The focus is 2 points or 2 spaces to the right of 4 and 3, so that would be 6 and 3. The directrix is always going to be an equation. It could be an x equals equation or a y equals. In this case, because the directrix it's vertical, we know that it's x equals 2 spaces left of 4 and 3 would be at 2. So x equals 2 is the directrix. And as you can see, the sketch is done. Excuse me, the focus, the vertex. The only thing I've kind of neglected here wasn't in the instructions, but for me, I like to go ahead and consider that lattice rectum, which would be this length right here. And if I've sketched this accurately, which I haven't, then this length right here would be exactly 8. In other words, up here, the top half of it would be 4, and the bottom half would also be 4. That's where the lattice rectum comes into play. It helps us to graph with a little bit higher level of accuracy. Now we're going to take a look at number 4. You can see they've kind of set this one up in close to standard form, but not quite. And the work we have to do is similar to what we did on number 3. So let's go ahead and actually fix this in terms of getting it exactly into the form we're used to, which would be that standard form. So it's going to be something like y minus 1 quantity squared equals, and I'm just going to put a negative 1 out here, even though we know that just a negative would do the trick, but I'm going to move that x plus 5 to the other side. It makes more sense in terms of the standard form for the conic. So again, finding p, it doesn't specifically say that anywhere in the instructions, but we always need to keep that in mind. So I'm getting a p-value here of negative 1/4. Now that's important for a couple reasons. One is it tells me how far the focus is from the vertex, etc. But again, also it helps with direction. Notice that we have a y squared term. This is not a function. That means it opens either left or right, and the negative tells me that it has to be left. So right now I actually have enough information that I could begin to do a little bit of a sketch of this this particular parabola. What I haven't actually mentioned is probably an important thing to mention before you get too far. That is the location of the vertex. The vertex is always, remember, h comma k, so this is going to be negative 5 comma 1. So what we know then right now is that our vertex is at negative 5, 1. Just going to put that right there, obviously just a bit of a guess. And we know it opens to the left because of a combination of y squared and a negative p-value. And the distance from the vertex to the focus is very small. It's only 1/4. Obviously I haven't quite drawn that to scale, haven't captured that, but that's okay. We're just approximating. It's a rough sketch for sure. We know it opens left. We also know the axis of, the directrix would be right there, also 1/4 of a space away from the vertex. So the focus point we know is a quarter space to the left of the vertex. So that's -5 1/4, comma 1. And we know the directrix is exactly 1/4, 1/4 space to the right. And so that would be x equals -4 3/4. If you'd prefer to write that as something like -19/4, that's totally fine, but it might make more sense just to leave it like it is. I'll leave that up to you. All right, let's go on to number 5. This time we're kind of working it back toward the clue problems again. So we've done a couple where we had to graph based on an equation. Now we're saying, here are some details, figure out what shape you're talking about. And I mentioned this before with a clue problem that honestly, you really should go ahead and just do a quick sketch. No precision is really needed. It's just a matter of getting an idea of not only the direction that it's opening, but also kind of see the vertex. And when you draw it, sometimes it helps in terms of finding that p-value as well if you're struggling to see that. So what I knew it opened down because the vertex was directly above. And because we know that p-value of -2, you can think of it as just a distance of 2. It also tells us that the directrix is going to be exactly 2 spaces above the vertex. All right, we don't necessarily need all that information. Nowhere in here did it say we needed the directrix. It didn't say to write down the p-value, but we do need to know some of the key stuff, like it opens down, the p-value is -2, and then I need to know which standard form I'm using. Well, this one is a function. We know that because it opens down. We passed the vertical line test, so we're talking about the standard form of x minus h squared is equal to 4p times y minus k. We're going to plug in the vertex, which we see right there. X minus the x value of the vertex is 1. 4p would be -8, and then I'd have y minus 5 for the rest of it. And there it is. All right, we found the standard form. All right, we're down to our last problem. Let's get through this one together as well. Find the standard form for the parabola that has the given focus and directrix. Okay, so again, I want to start with a little sketch, and let's just think about the situation here. And that would be a focus at -2 and 5. I'll just approximate that to be there. Directrix is x equals 1, 2, 3, 4. So we'll grab a little dashed line here and put it there. Okay, I've done nothing but just approximate this. I've drawn it. But what I do know is that this distance is 2, this distance is 4. So the gap between focus and directrix is 6. Now if you think about it, there's something missing in between those two, and that thing that's missing is our vertex. Okay, the vertex has to be right there where this p-value right here would be 3. The distance would be 3, although it is in the negative direction to be fair. And the graph would have to open to the left, like you see there, away from the directrix, around the focus point. All right, because it opens to the left, we know it's again not a function. So we're going to have this form, y minus k squared is equal to 4p times x minus h. I already wrote down up there that p was -3, but I'll go ahead and reiterate. We didn't actually write down where the vertex was. We figured out where it was because it was 3 spaces from either the focus or the directrix, right in between, and that actual ordered pair for the vertex would be 1 and 5. Again, that point is 3 spaces right of the focus and 3 left of the vertex. So we can finish the job right here by doing y minus 5. That's the y value of the vertex. That's your k. 4p would be -12, and then x minus h, which is 1 in this case, and there's your standard form. All right, folks, so I know conics are a thing we've seen in the past, and more specifically parabolas are a thing we've seen in the past. It's a little bit new way of looking at it. It's a little bit of new terminology. I'm really going to stress when you graph that we get that lattice rectum figured out. It's got a funny name, but it's a useful little tool that allows us to graph with a lot more accuracy than just eyeball graphs, especially if you have graph paper available. All right, folks, you guys have a fabulous day, and we'll see you soon.